Basically something called this SageMaker has this tool called AutoML. So here you can see the SageMaker dashboard, and this is autopilot. Automatically train and tune ML models in SageMaker Canvas with no-code workbook and build generative AI solutions. So here you can see the metric, right? Root mean squared error is 4.261, right? And that means that the square root of the sum of the predicted values minus the squared values. Well, it's a lot easier to actually understand this. The mean absolute error, like the mean absolute error, like if you say that is 3.17, or r squared is about 0.695 or 0.7%. So 70% of the variation in the crash score is explained in the model. And I compare that to the MSE from this like really long study that we had conducted, where it's about 4.28 for a GLM, or for so 4.286 compared to 4.261, right? So it's actually better. And literally, this took me about one click, about 5 minutes of time, to just import it into SageMaker and press AutoML. Done. And I did another study with another data set that I know very well, and I had this is the health costs. So it looks at a person's age, sex, BMI, number of children, smoker status, region, and then it predicts the annual health charges of that person. And where do I do this? This is a smaller data set. It's only about 1,300 observations. Where do I look at the model? So this is the data set models. This one. This MSE, well, MAE was 2602, or in dollars, that's $2,600 per year. And when I looked at that compared to, my version from the predictive analytics exam, I did all these steps: hierarchical clustering, feature engineering, GLMs, fit a GBM, etc., validate the GBM, and that was it. Mean absolute error 2,561 versus 2,600. So this one, it actually came out a little bit worse. Yeah, so autopilot 1, it on the bigger data set, on the larger data set, it was better. On the smaller data set, this manual worked better. It's SageMaker Autopilot. It's running, it uses all these parameters, and it looks across these types of models: a neural network, Torch, LR, RF, XT, XGBoost, GBM, CatBoost, Fast AI. You're probably familiar with fast.ai. It's like a website that builds neural networks. CatBoost, it's another type of gradient boosted tree model. Neural network from Torch, PyTorch, LR, linear regression. So it just kind of runs an algorithm that tests out all of these things, all of these models. And it's also scalable because this is running this on a EC2 compute instance, so that this can actually be made bigger if you have larger data sets.